This is segment 7 of the Module 7 lecture, and this covers primarily section 8.3 in the textbook. All right, in here we're going to learn to construct a confidence interval limit, but now we're going to use the sample mean and the sample standard deviation. And I wanted to emphasize that if you knew the the population standard deviation, then you must know the population mean, because if you remember in module 3, I show you the formula how to calculate the population standard deviation, and we had to use the population mean. Therefore, I'm not going to focus on the part of the text where they assume that the population standard deviation is known. I'm going to focus on the section where that relies on the sample statistics, the mean and the standard deviation. So in your book, this it shows this diagram, and this section where it says the standard deviation of the population is known, I'm not going to cover it except for the discussion on sample size, and that the sample size will be discussed at the end of module 7. I'm going to focus on section 8.3, where we know that the sampling distribution is normal, either because the population distribution is normal or because the sample size is large. In the case where the sample is small and the distribution is not normal, we're not going to discuss it. That's beyond the scope of the text. All right. So when the population standard deviation is replaced with the sample standard deviation and the sampling distribution is normal, then this statistic, this t statistic, follows a t distribution with n-1 degrees of freedom. And if you compare this definition of the t statistic with the c statistic that we used in the previous segment, then you see that these two equations are identical. The exception is that the t relies on the mean of the sample and the standard deviation of the sample. And that's what we know from the sample. So we want to use this t distribution. Now the t distribution is similar to the standard normal distribution in that it is bell-shaped and symmetric. The area under the curve is 1 as the standard normal, and now the t distribution is defined by a single parameter called the degrees of freedom, and that's defined as the sample size minus 1. And then you will see for each sample size there is a different t distribution. So we don't have a single t distribution, we have many t distributions. And the t distribution is also centered on 0, so its mean is 0, but its standard deviation is always larger than 1. And only when the sample size is very large, then the t distribution becomes the normal distribution. All right, to get probabilities from the t distribution, we're going to use table 5 that's posted on Blackboard. Please print it and use it for your homework, and you're going to use it for your exam. And here are the key difference between this table, table 5 and table 4. Number 1, each row is one t distribution. The probabilities at the top give you the probability to the right of the t-value. The table 4 gives you probabilities to the left, but this table gives probabilities to the right of the t-value. So you find the degrees of freedom of the distribution that you're looking for, and then you find the probability on the right side and find the corresponding t-value. Here is an example. So we want to find the t-value that goes with this probability of 0.05 on the right side, because we're looking for t being bigger than t sub 0. And we have a t distribution with 16 degrees of freedom. So to find that t value, first we identify the probability, 0.05. Then you go down that column until you find the row for the t distribution with 16 degrees of freedom. And the t value is 1.746. So that's how you find the t-values. Now, if you need to find the t-value on the left side of the distribution, in that case, you use the probability to the left but you take it as if we were to the right, and you find the t-value on the upper tail, and then the lower value for the same probability on the lower tail will be that t-value, but negative, because the t distribution is symmetric around the mean of 0. All right, so how do we get the confidence intervals with the t distribution? Well, in this same exact manner as I showed you in the previous segment. So we use the confidence level to find the upper and lower probabilities, or the probabilities in the lower and upper tails. And then we use the probability in the upper tail on table 5 and the degrees of freedom of the t distribution to find the t-value. And then we replace that t-value and the sample mean and the sample standard deviation and the sample size into the equations I showed you before. And so this is how we calculate the lower limit and the upper limit of the confidence interval for the population mean. In fact, the book shows you that the confidence interval limit for the mean is defined as this, but in the slides I'm going to be working with these two equations because they give you explicitly the limits, the lower and upper limits of the confidence interval. Also note that in the case when we use the t distribution, the margin of error is defined as this, with the t-value and the sample standard deviation. All right, let's look at the first example. So in here, a researcher selected 16 coffee shops of a particular chain and measures the temperature of the coffee that they are selling. So he found that the sample mean of those 16 temperatures that he collected is 162 degrees Fahrenheit, and the standard deviation is 10 degrees Fahrenheit, and he wants to calculate the 95% confidence interval for the mean temperature. And now it is assumed that the temperatures are approximately normally distributed, which makes sense because they have a temperature controller that keeps the temperature of the coffee almost constant, but varies randomly about that whatever temperature they set. So that makes sense. All right, so when you solve these kind of problems, the first step is summarize the information so that you don't make any mistakes when you calculate the confidence interval. Step 2, verify that you can use the t distribution. So the first step is the sampling distribution normally distributed? In this case, it tells us that the population is normally distributed. Then we know that the sampling distribution is normally distributed. The second thing that we need to know is that the population standard deviation is not known, but we know the sample standard deviation and we're going to use it. So that fact and the fact that the sampling distribution of the mean is normal, it tells us that we should be using the t distribution. All right, so now using the confidence level, which in this case is 95%, then from it we can find that alpha is 0.05. And because this is a symmetric interval around the mean, then we know that the upper probability is going to be the half of this 0.05, which is 0.025. With that probability and the degrees of freedom, which is the sample size minus 115, we go into table 5 and we find that the t-value is 2.131. Please verify this value using your own t-table. Make sure that this is correct. Once we have all this information, then we put them into the equations for the upper and lower limit of the confidence interval. You carry out those calculations, and here we find the upper limit and the lower limit of the confidence interval. So the last step is to interpret the confidence interval, and we use what I showed you in the previous segment. And so we say that the mean temperature of the coffee sold at all the coffee shops of this chain is between 156.67 and 167.33 degrees Fahrenheit with a 95% confidence level. All right, so this is the first example. Let's look at another example. In this case, a manufacturing company produces electric insulators. I put a picture of those things here. And a key characteristic is its strength. So if these insulators break, the two electrical cables come together and there is a short circuit. So this is a key characteristic. And in this case, a total of 30 insulators were randomly selected and tested. And they found from those 30 measurements that the sample mean is 1,723.4 newtons. And the standard deviation of the sample is 89.551 newtons. And we want to construct a 99% confidence interval estimate for the mean strength of the population of insulators. All right, as in the previous example, gather all your information, write it down so you don't make any mistakes when you calculate the confidence intervals, or the confidence interval rather, and then verify that you can use the t-distribution. So here they don't tell us what the population distribution of the insulators is, but we know we have a sample size of 30. So based on the central limit theorem, we can say or safely assume that the sampling distribution of the insulators is normal. Now, we don't know the population standard deviation. We replace it with that sample standard deviation. So given those two facts, then we know we can use the t-distribution. All right. So now from the confidence level, which is 99%, we find that alpha is 0.01. We divide that by 2 because we're splitting that probability in the lower and upper tails of the t-distribution. So that probability is 0.05. And with the degrees of freedom, which is the sample size minus 1, which is 29, we go into table 5 and we find that the t-value is 2.756. Please verify that this number is correct. And that way you practice using table 5. So now you replace all the values that we have, the sample mean, the t-value, the sample standard deviation, and the sample size. You conduct these calculations and you find the upper limit and the lower limit of the confidence interval. So now the next step is to interpret those confidence, that confidence interval. And so we say that there is a 95% confidence level that the actual average force, mu, required to break an insulator is between 1,678.43 and 1,668.46 newtons, which is kilograms per meter divided by square seconds. All right, so these are the two examples I have for you. I know I saw a couple of mistakes. I will correct them and repost the slides so that when you look at them, there is no confusion. All right, I will stop here, and in the next segment, we'll talk about the confidence interval for the proportion.